Hey guys, this is Michael, and I'm going to be showing you guys the second question of the Unit 1 Progress Check FRQ. So, if you can see here, this is the little image that they give you, and it's an astronaut, and he's holding a rock 100 meters above the surface of planet X, and then the rock is thrown upwards with a speed of 15 meters per second as shown in the figure. And the rock reaches the ground 10 seconds after it is thrown, and the atmosphere of planet X has a negligible effect on the rock when it is in free fall. So the first question it asks us to solve is to determine the acceleration due to gravity of the rock when it is on planet X. So in order to answer this question, we have to use the details and little statistics that they give us in order to figure out what the acceleration is. So the first thing we know is the change in y is negative 100 meters. So we know that the change in y is equal to negative 100 meters, and this is because delta y equals to y2 minus y1. And so if the astronaut started 100 meters above the ground, y1 is 100 meters. And then y2 would be 0 meters because that's where the rock is hitting the ground. So 0 minus 100 equals to negative 100 meters. So what else do we know? We also know that the rock reaches the ground 10 seconds after it is thrown. So we can write down that time equals 10 seconds. And we also know that the initial velocity is equal to 15 meters per second, which is the speed at which the rock was thrown up. And the question is asking us to determine the acceleration. So we're just going to write acceleration equals question mark because that's an unknown value that we're trying to solve. So now that we have all of this written down, we can use a formula to calculate what the acceleration is. So now if we rearrange this formula, we can isolate acceleration. So next we plug in our values. And if you put that into a calculator, we should get that acceleration equals to negative 5 meters per second squared. So just like that, we have finished question number 1, and we will be moving on to question number 2. So question number 2 asks, how does the speed of the rock when it reaches the ground compared to the speed of the rock when it's thrown upwards? So this VU stands for the velocity upwards, and the VD stands for velocity downwards. And then so if we look at this, we could already just right off the bat know that this is the correct answer right here, and that the velocity downwards is greater than the velocity upwards. And I'll show you why I know this right away, because if you look at the little diagram again, when the rock is thrown upwards, this is the velocity upwards right here. When it comes down, it's going to also come back at 15 meters per second until it reaches the astronaut again. But compared to the upwards velocity, this still has the rock still has 100 meters down before it reaches the ground. So during these 100 meters, the speed is just going to accelerate, and so thus the velocity downwards would be greater than the velocity upwards. So let's just write that down real quick. So just to recap a little bit, all I'm saying is that since the rock still has 100 meters downwards to go, during these 100 meters, the rock will continue to accelerate in this negative direction, which will result in the velocity downwards being greater than this velocity upwards. So yeah. So we're going to move on to the final question in the FRQ, and that is, a student wants to know how the motion of the rock would be different if it was thrown upwards at 15 meters per second from a height of 100 meters above Earth's surface. In a clear, coherent, paragraph-length response that may also contain figures and or equations, explain how the motion of the rock on Earth will be different from its motion on planet X in terms of maximum height above the ground, the speed at which it reaches the ground, and the time in which it is in free fall, and its acceleration due to gravity. So just from reading this little question, it's pretty clear what College Board wants us to state, and so those is pretty much 4 main points that could be earned from this question. And so because it asks us what the maximum height above the ground, the speed at which it reaches the ground, the time in which it is free fall, and its acceleration due to gravity. So we just have to identify what those 4 main points are. And let's put this here. So since Earth has, first off, we know that Earth has a greater acceleration, or on Earth the rock has a greater acceleration because the gravity force is 9.8 meters per second, but we're just going to use 10 to simplify it. And so since 10 meters per second is a greater acceleration than the negative 5 meters per second squared, we know that on Earth, the rock will have a greater acceleration. So that answers one of the points already, which is just the acceleration due to gravity. So let me just write this out real quick. And so I wrote negative 10 meters per second squared is greater than minus 5 meters per second squared, but we know that, of course, everyone knows that negative 10 is not greater than negative 5, but since we're talking about acceleration here, we're just saying that it's accelerating faster. So since we know that the acceleration is greater on Earth, we also know that the rock will be pulled down to the surface more quickly. And as a result, the time of flight, which is another one of those points, is less on Earth. So I'm just going to write down what I just said. And just to clarify, I said that the time of flight is less on Earth, but on the question it says the time in which it is in free fall, which is just the same thing. So we're going to move on to the next point, and that point is the maximum height above the ground. And we know that the maximum height above the ground is less for Earth since the rock is being pulled down more quickly. So we're pretty much saying that since the rock is accelerating downwards more quickly, then less time is being spent accelerated upwards, resulting in a maximum height which is lower on Earth rather than on planet X. So the last point that we have to identify is the speed at which the rock reaches the ground. And we know that the speed at which the rock reaches the ground is greater on Earth than on planet X, because the rock is accelerating through the same distance but at a greater rate on planet Earth. So it's going to result in a greater landing speed. Alrighty, so with that, that concludes all the questions in this question 2 FRQ. Thank you.